Can we discuss?
Say again,
Can we discuss the questions later or now also can?
we are going to finish a little bit, just cover a little bit special resistor, that's all. Thermistor and LDR.
Okay.
After that, we will solve problem for you. Okay, so these are the different symbol that you may need to remember. Right? Light dependent resistor is how it looks like. This is how the symbol looks like. Cadmium sulfide is a semiconductor material whose resistance varies with the amount of light falling on it. Made by sandwiching a film of cadmium sulfide between two metal electrodes. All you need to know about light-dependent resistor will be, or LDR. And LDR is sensitive to changes in light intensity. The change in resistance to intensity is not linear, right? Not a straight line. As light energy is absorbed by the material, electrons and positive holes are released and become available for conduction. Right? So light energy release electrons and holes, so it becomes conducting, low resistance. In moonlight, the resistance is 1 mega ohm, that means almost dark lah. In sunlight, resistance is 10, about 100 ohm, very low lah, low resistance. LDR are used in electronic circuit to operate light sensitive switches. For example, they can be used to switch on light automatically when daylight gets too dim. That's the symbol. Thermistor, that's how the different thermistor looks like. Thermistor can be used in circuit which senses temperature change. For example, a thermostat to keep the temperature constant, or an alarm if the temperature gets too high or too low. Huh? Just to trigger an alarm to tell you something is wrong. In freezer, if it's too low, then the alarm will sound. Or sometimes if it's too high temperature, that means there's a fire, then the alarm will sound. Depend on what you're used for. This is the rod type lah. If it comes out in the exam, it's usually this type lah, in the Cambridge exam practical. Right? Made of semiconductor material, a rise in temperature releases electron and positive hole, improving the intrinsic conduction of the material, so lowering its resistance. Right? So this is specially designed so that when the temperature increases, it's a semiconductor material, electron and holes are available for conduction. So it means that the resistance decreases as the temperature increases, different from our normal wire, where the temperature increases, resistance increases. Right? That's the symbol. That's how it looks like for thermistor. A plot of
Wait, when the temperature increases, resistance decreases.
yep, because
Okay.
electrons and holes are available for conduction. A plot of resistance against temperature graph is shown. This is called negative temperature coefficient, NTC. This one you are interested in, this one, not the other one. The other one is positive temperature coefficient. We are not interested in that. Right? We are interested as the temperature increases, the resistance become less. Okay, we won't bother about this one. Being initially cold, they are high temperature, thermistor lah, before current flow in them. And so they can be used to prevent high current through a lamp filament and electric motor at the moment of switching on. Right? So to protect your filament lamp and your electric motor lah, because when it's cold, it's high resistance, so little current will flow. only air is heat up, then resistance will decrease. Thermistor sometimes operate thermostat and fire alarm as their resistance change can be used to switch on electric circuit when the temperature changes. Okay, so we have covered more or less summarized for you in this picture all the formulas that you need to know how to use. Okay, and these are all the other extra that we have covered. Okay, but answer for you. Answer your question. Question what?
Okay. Starting from question 8,
Question 8.
I got 6.
Question 8, we have calculated, we have done already.
Oh, really? Oh, yeah, sorry. Yeah, correct. Done already. Okay, question,
Only question 11 we have not done, no?
question 11.
This is an ideal diode. You should know how to calculate. Just read from the graph, that's all. 0.2 volt horizontal, 0.2 volt is here, 0.2 is here. So no current. So it's infinite, no? When it's horizontal for this type of graph, infinite resistance, 4 volt,
Can I put potential difference 0?
cannot. The resistance is not zero, the resistance is infinite. No
Oh,
current flow,
infinite. Oh,
no current flow means infinite resistance, no?
oh, okay.
And 4 volt, 0.4 volt, 5 milliampere, calculate out, convert it to ampere, 80 ohm, and for 6, 0.6 volt, 0.6 volt is about 10, 12 volt, 12 milliampere, convert that, so it's 50 ohm. So this one is calculation is just to show you that the resistance decreases as the PD increases. Okay,
Okay.
whereas for this is the reverse bias,
Oh,
20 microampere, 20 microampere is here, right? It's 20 ohm, 10 ohm is here. Usually we won't bother
1
about.
mega ohm, is it?
Say again,
That one is 1 mega ohm.
this one is microampere.
Oh,
The M is mega ohm.
mega ohm, okay.
So depend on where you read it, the current is the resistance is very high. So you won't bother about F lah. F is more
Oh,
challenging.
is it because it's very small? Then the resistance higher, right?
The current is very small.
Ah, yeah, then
At
resistance
high
will become
voltage,
very
the
high.
current is very small.
Okay.
That's why it's mega ohm. But the other one you won't bother lah, unless you want to try it out lah. You can try it out yourself. Challenging. Uh, Try this one using the formula. That's all. Remember to convert it to meter. Calculate the cross section area in meter square. Can
Yeah.
should be able to get 0.013 ohm.
R square.
Calculate your cross section area in meter square.
So rho is the resistivity, is it?
Rho is resistivity.
Okay. Mm.
Try this one. This one is just to test you whether you know how to read which is the length, which is the cross-sectional area.
Eh,
Can A the current is flowing in the direction of X. So that is the cross-sectional area. No? Length is 10 cm. No? Convert everything to meter.
okay.
Right? Next example is B. Current is current is flowing upwards in the y direction. So that is the cross-sectional area. And then this becomes the length. No? Length is parallel to the current. No? Can
Uh,
I think we can call it a day unless you got question you want to ask. You must try the question, you know. If not, it's a
oh yeah,
waste.
but
To give you tuition is a waste. You are supposed to know how to use the formula. You don't
okay.
use it, you lose it. Okay, any question you want to ask? If not, we'll call it a day.
Uh, I don't understand how you like see the length
That's the
L, which one is
current.
L, which one is A.
The current is the y direction. So this is the cross-sectional area. Then
Oh,
this becomes
then
the length though.
oh oh okay, I understand already.
Length is parallel to the current.
Yeah.
Cross-sectional area is where the current come out.
Yeah. I think I understand.
Okay, any question you want to ask? Or you want me to show you?
Um, have you completed the chapter?
We have finished already. So next week we'll go
Oh,
to DC
so finish
circuit.
chapter.
We finish this chapter already.
Next week which chapter are we doing?
DC circuit, topic 10. I've given you the note already.
Oh, okay. My exam is until chapter 11, the nuclear one.
Oh, okay.
I find that chapter quite hard
Okay.
because it's a lot of chemistry involved.
No lah, all physics lah. Where got chemistry?
No, the chapter 11 the nuclear,
Chapter
a
11,
bit of
nuclear physics
chemistry.
lah.
Uh,
Okay, any question you want to ask? If not, we'll call it a day.
yeah, sure.
Any
Okay,
more?
let's call it.
Any more thing you want to ask?
Don't have.
Okay, so we'll stop here lah. Have a
Alright,
good
thank you,
rest.
teacher.
Okay.
Thank you.
Okay, bye bye.
Have a good night.
Okay, good night.